All right, so we have P3 transformations of absolute value equations. So all of these are written in the form y, well, they maybe not be written in it, but they can be manipulated into the form of y equals a times the absolute value of x minus h plus k. And there's a lesson on this where I did the lessons also on YouTube. Now we're going to do a lineup process here. You can clearly see here that a is negative 2. And we kind of think of that as our slope. All right. Now we might struggle a little bit with like what is h. So for some kids you have to understand the understood, and it's always understood that there's a 0 that can be added to anything. Now this gives us our h and our k. Now for things like h that are kind of stuck in prison or absolute value bars, the sign changes. The form is x minus. But anyways, on this example, the vertex here, we have an h value of 0, and we have a k value of 3. So we have a vertex at 0, 3. That's a 0. That's where your vertex is. Transformations that are present here. If a is negative, which this one is, we have a reflection over the x-axis. So it has been reflected over the x-axis. There is an x-axis reflection. Now, if we take the absolute value of a, the absolute value of negative 2 is 2, that tells us that we have done what's called a vertical stretch. So there is a vertical stretch factor 2. This thing grows twice as fast as it would otherwise. Since the vertex, and maybe we'll plot it and look at it first, but the vertex is at 0, 3. So this thing has literally shifted right 3 units. Sorry, I did that backwards. Bad Milbrath. 0, 3 would be up 3. There we go. This thing has been shifted up 3. So we have a vertical translation up 3. Now, let me go back and reread the instruction set here. So, graph the given absolute values, identify A, the vertex, state the transformations present, and the domain or range. Now, if this is the first video you've watched on what absolute value looks like, let me go off to the side and do mom. Y equals absolute value of x, because if you didn't know what that looked like, you wouldn't understand any of the transformations I did. Absolute value of x has 3 key points, 0, 0, negative 1, 1, and 1, 1. And it looks like that. So when I talked about this thing being shifted up 3, that's what I had. Plain and simple, the thing was shifted up 3 because mom was at the origin, this thing went up 3. Now this thing has a slope of negative 2. What that means is that we move left or right, we are going to fall 2 units from our initial starting point. And we're going to look something like this. Now, I think I might modify this homework assignment and maybe have you make a table, because I think that might lead to some better understanding. Now, our h value was 0. We'll center at 0. We'll plug in a negative 1 and a positive 1, something to the left and something to the right. You know, when we forget what to do, we can always fall back on tables. We can always fall back on tables. So left of 0 is a negative 1, and we'll plug that into the equation. This will become 2, negative 2 times a negative 1, sorry, the absolute value of negative 1, add 3. Now, the absolute value of any number on its own right is just the number inside. So this becomes negative 2 times 1, add 3. And if we do the math there, don't be surprised at what you get. You get 1. Plug in a 0. Negative 2 times the absolute value of 0 plus 3. Well, anything times 0 is 0, so there's your 3. Plug in a 1. Negative 2 times the absolute value of 1. Add a 3 back. We'll have negative 2 plus 3, which is 1. So that's the math behind those points, okay? Now, domain and range. Domain is always inherited from the parent. And the parent had a domain of negative infinity to infinity. And domain is always inherited by its parent. So the domain here is still going to be negative infinity to infinity. Range can change. The range on this one's a little funnier. this thing has a low value of negative infinity, and it rises to 3. So that's a little different. Now, I don't talk about set builder notation as long as I should, but if you're a fan of set builder notation, and this is optional, all values of x such that x is an element of the real. Over here, this would be an inequality statement. All values of y such that y is less than or equal to 3. And there's your two forms for domain or range. All right, let me pause this and erase and move forward so I don't eat up your time. All right, let's move on. I'm only going to do about half of these. So here's number 4. Identify A. Again, think of the lineup process. A times the absolute value of x minus h plus k. So A here is going to be 1/2. And again, think of that as slope, okay? That's kind of what it is. The vertex here, when we leave these absolute value bars, we're going to change the sign. The vertex is going to be at -3. We're going to trust the next one, -5. So your vertex is at -3, -5. Now, it might make sense for a kid to graph it before they kind of talk about what the transformations are. So we'll go ahead and do that first. And we'll go ahead and do a table, because tables are important. So to get to our vertex, we go left 3 and then we fall 5. Please don't be the kid who doesn't understand how to plot points. You need to fix that, because I have no idea how you made it to Algebra 2 if you can't plot points. I don't have a clue. And it's not something you should forget. It's plotting points. Now, we have a slope of 1/2. That means we're going to rise 1 and run 2. We're going to rise 1 and run 2. On both sides, rise 1 and fall back 2 on the left, because we're doing absolute value and we have to draw a V. So, let's talk about what's happened, okay? Now, the transformations here are that we had two translations. We translated left 3 and down 5. So we had a horizontal translation left 3 and we had a vertical translation down 5. A is not 1, so something happened. What happened is the thing got wider. Now, if you push down on something, it gets flatter, right? So we had what's called a vertical compression. And the factor is 1/2. Sorry about the markers. I'm waiting on new ones. These are starting to run dry. We had a vertical compression. Now, I just said in the previous problem that domain is inherited from mom. And mom had a domain of negative infinity to positive infinity. And so does this graph. It runs left forever and it runs right forever. So the domain is still negative infinity to infinity. And again, if you like set builder notation, all values of x such that x is an element of the real. The range is going to change, like it just does. The range changes a little bit. So the range here is we have a low value of -5. That's the low value. That's kind of in the way there, isn't it? There we go. A low value of -5, and then we rise to infinity on both sides. Notice the brackets, solid point. I told you if you can put your pencil on it, it's going to be a bracket. If it's a solid dot, it is. If you like set builder notation, the relationship here is that we're 5 or higher. So all values of y such that y is greater than or equal to 5. All right. I'm going to do half of these. I'm not going to do all of them. Let me pause and erase, and we'll restart on, I guess, number 6. All right. Moving on to 6. Here we have f of x is 1/2 of -4x plus 8. So a lot of kids will look at this and they'll tell me that the vertex is at -8 too. We're going to do something. We're going to do FAFO, which does not mean what you think it means. FAFO, factor and find out, okay? Doesn't mean F around and find out. It means factor and find out. So absolute value is kind of cool in that you can actually pull multiples out of things. So let's start with what we have. And what we're going to do is we're actually going to pull the -4 from inside. Now, if I pull a negative 4 from a negative 4x, there is an x left over. And if I pull a negative 4 from a positive 8, there's a minus 2. Kind of think about your distributive property. You pulled that piece from both. And then, of course, we have the plus 2 on the outside. Simplify, and we'll have y equals negative 2 absolute values of x minus 2 plus a 2. Okay? That's what you got. I forgot to do a table on the last one. But anyways, I'll do a table on this one if I can remember. Now, where or what has happened? Well, A has an actual value of negative 2. That's your slope. Your vertex is at positive 2, okay? Change sign, keep sign. And the transformations that have happened, I'm going to do this one without graphing first, okay? The transformations that have happened. The negative sign tells me there has been a vertical reflection, or x-axis reflection. Doesn't really matter what's going on here, but there's been a vertical reflection. Since we have a value of 2, the absolute value of negative 2 is 2, we have a vertical stretch. And we have had some shifting happening because the vertex is telling our shifts. We have a horizontal shift, or a horizontal translation, right 2. We also have a vertical translation, which is up 2, okay? And that's all of the things. Now, maybe you're a kid that needs a table. This is your initial x, okay? So let's go off and make a table. We center around an x value of 2. 1 unit before 2 is 1, and 1 unit after 2 is 3. And then we plug in, and this might be kind of hard for some kids, you know, just basic computational. Let me find some free space over here. So if I do negative 2, there's an x, I make it a 1, absolute value of 1 minus 2, and then plus 2. I'm going with my modified equation here, plus 2. I'd have negative 2 absolute values of negative 1 plus 2. The absolute value of negative 1 is 1, and negative 2 times 1 is negative 2, and negative 2 plus 2 is 0. So if I plug in a 1, I get a 0. Now I got $100, says I plug in a 3, I'll get a 0 back, because these things have what we call symmetry. They do, symmetry. So let's see what happens if we plug in a 3. This becomes x minus 2, so 3 minus 2, and then plus a 2. We'll have negative 2 times the absolute value of 1 plus 2, and that's going to be negative 2 plus 2, which is 0. So the only interesting point there is going to be what happens at 2. And I think it's going to generate a 2 back, at least it should, because look right there. Negative 2 absolute values of 2 minus 2 plus a 2 is negative 2 absolute values of 0 plus a 2. 0 times anything is 0, and 0 plus 2 is 2. So there's a table, and tables are good things to fall back on if you forget what happens. Of course, they take work, and kids aren't going to do that. But there's a table. And let's get this thing graphed. So I'm not going to look at the table. I'm going to look at what we talked about. We had a vertex at 2, 2, to the right 2, up 2. We had a slope of negative 2, so fall 2 and run 1. And if you'll look at those points I plotted, they should match what's in my table. Now again, the domain is the same as mom. Domain is always inherited by its parent. And the parent had a domain of negative infinity to infinity. Range is going to be different on a lot of functions. On this one, this thing has a low y value of negative infinity. And has a high y value of 2 with a bracket. Now, a lot of you probably will not write down the set builder notation that I do. You know, that's at your own peril, okay? What's happening is the relationship with y is that y is less than or equal to a positive 2. And there's your set builder notation. All values of y such that y is, no, that's hard to see on your end, less than or equal to 2. And there you go. One more to go and we're done. course, this one's got a fraction in it. Oh no, therefore we will automatically not do it. That's how it tends to go. If there's a fraction, kids freak out. What do we have here? We have negative 2/3 of x plus 3 minus 2. The nice thing is that while it has a fraction, you don't have to do any factoring because it's already in the correct form. It's a absolute values of x minus h plus k. So it's already in a perfect form. Let me scoot this up a little bit. There we go. A is going to be negative 2/3. Again, that is your slope. Your vertex, change, keep, is at negative 3, negative 2. I'm going to go ahead and start graphing this thing. Back 3, down 2. I'm also going to go ahead and kick in slope. The slope is negative 2/3. I am going to fall 2 and run 3. Fall 2 and run 3. Now I got a pretty wide V here. Remember, it's absolute value with a V. All right, transformations. Now obviously this thing's upside down. It's upside down because of that negative symbol there. I've done that in a couple ones in the past here. So what we have here is we have a vertical reflection. And we also have some horizontal and vertical shifts. There is a horizontal translation or shift. I actually like the word shift. There's a horizontal shift of left 3, and there is a vertical shift of down 2. And now we get to talk about domain range. Now, it's a V. The domain of any V is going to be from negative infinity to positive infinity. Close. Negative infinity to positive infinity. My range here, we have a low y value of negative infinity and a high y value of negative 2. And again, set builder notation, all values of y such that y is less than or equal to negative 2. And that, boys and girls, is half your homework. You're very, very welcome.